So a question was asked about how to number cycloalkanes in order to get the lowest sum of substituent numbers. So let me just start with the idea of let's say we have a cyclohexane, and let me put a chlorine here, a bromine here, and a methyl group down here. So, well, the first thing that we need to do is we need to be able to name these. So we have a chloro. Usually I try and make sure that I name these. So this is a chloro. A bromo. And then we have a methyl group. And I name them first because that way I know, if I need to use alphabetization as a tiebreaker, I already have the groups named. So the idea here is that since there's no beginning or end like there is in a non-cyclic alkane, a beginning or end of a chain, we have to somehow figure out which carbon to start with and then whether to go clockwise or counterclockwise. So the rules are going to be that number one, we must have the lowest sum of substituent numbers. So we can try numbering starting at a group, going clockwise or counterclockwise, and seeing which one is going to give us the lowest total sum of the substituent numbers. So let's just say, for the sake of argument, we decide to start at bromine number 1. So bromine, we could go 1, then 2, then 3, then 4, then 5. So the sum there would be 1 plus 2 plus 5, which would be 8. Can we do better than 8? We actually could if we went chlorine 1, bromine 2, that carbon 3, and then the methyl group 4. That would give us a 1 plus 2 plus 4, which would equal 7. So is there any other starting point going clockwise or counterclockwise that would give us a lower total sum of substituent numbers? And the substituent numbers basically are the numbers that have of carbons that have a group attached to it. And there really isn't another. If I started with something like the methyl group and go 1, then 2, then 3, and then 4, I would end up with a 1 plus a 3 plus a 4, which would be 8. So the red, in this case, is the best numbering scheme. It's the one that gives us the lowest sum of substituent numbers, which in this case would be 7. Okay, so as I'm going through, I would say, okay, here's my chlorine, here's my bromine, here's my methyl, and my numbering scheme has to be 1, 2, 3, and 4. And so that's my lowest total sum of substituent numbers, which is rule number 1. And so then if I was naming this, I would now alphabetize these substituents. I'm going to have a 1, let me erase the bracket, I'm going to have a 1 chloro, a 2 bromo, and a 4 methyl, so that the name of this molecule would be, now alphabetizing the substituents would be 2 bromo, 1 chloro, 4 methyl, cyclohexane. And so that would be the name of this molecule. So that's rule number 1. You've got to come up with a numbering scheme that gives you the lowest total sum of substituent numbers. Now, there's some tiebreakers that you can use along the way here. For instance, in this molecule, there is only one numbering scheme that clearly gives us the lowest sum. And so if there's only one numbering scheme, then that's the one we have to use. Let's say I change that a little bit. Let's say I had a methyl group here, maybe a bromine here, and an ethyl group here. So this group is a methyl, this is a bromo, and this is an ethyl group. So again, I name these because if I need to use alphabetization, I could do a tiebreaker. So in this case, I have to start at either the methyl or the ethyl and go clockwise or counterclockwise. So if I start with methyl and go 1, 2, 3, that's a 1 plus a 2 plus a 3, which makes 6. If I start with the ethyl and go 1, 2, and then 3, I still have a 1 plus a 2 plus a 3, and that equals 6, so I'm tied. So now, in terms of my number 1 rule of having the lowest sum of substituent numbers, I now have to go to rule 2 because I have 2 schemes that give me the same lowest sum. So if that's the case, and it's only if you have more than one numbering scheme, then what I would do is now I'm going to go ahead and I'm going to start at the first alphabetized substituent in that scheme. So in other words, I'm either going to start with methyl or I'm going to start with ethyl. Well, which one comes first alphabetically? Ethyl. So I'm gonna start with ethyl and go counterclockwise. So my numbering scheme is going to be ethyl, bromo, methyl. So now if I wrote the name of this, again I'm going to alphabetize the substituents. So this is a 2 bromo, 1 ethyl, 3 methyl, cyclohexane. Okay. So that's a tiebreaker if you have more than one scheme that gives you a lowest total sum of the substituent numbers. Okay. But that you only start at the first alphabetized substituent if you have that tie. Okay, so let's do a third one here. Okay, so looking at this, I have to come up with a numbering scheme that has the lowest total sum of substituent numbers. And here's the numbering scheme. Here's where I'm going to start. I'm going to start at the carbon with the bromine and methyl group attached. And you might say, why? Well, it's not because bromine's first alphabetized. That's not the reason. The reason is because if you have two substituents attached to the same carbon, you add those numbers twice. So in other words, if you have two groups and you number them starting at 1, you're going to get a 1 plus 1. If you had a numbering scheme where they were 2, it would be 2 plus 2. And so mathematically, the only way you're going to get the smallest total sum of substituent numbers is to start at the substituent with the two groups. You have no choice. So in this case, this could be a 1 plus 1 plus 2 plus 6. Or it could be a 1 plus 2 plus 6. Okay. So if I start at the bromine and methyl group carbon that's attached to that carbon, I can go either clockwise or counterclockwise, and I'm going to get the same total sum of substituent numbers, which in this case is going to be 10. Okay, I can't get anything lower than that. And you can try, but you have to start at the bromine methyl group carbon with number 1. That's the only way you're going to get the lowest total sum of substituent numbers. So now I got to break the tie, and so my choice is I can either go start with 1 and go counterclockwise to get ethyl, or go clockwise to get chloro. So now what I'm going to do is I'm going to break this based on alphabetization. And so who comes first? The ethyl group or the chloro group? And the chloro group would come second alphabetically. Again, the only reason I'm breaking this tie is because those two schemes give the same total sum of substituent numbers. So if I rewrite this over here, I'm going to go number 1, then chlorine number 2, then 3, 4, 5, and 6. So I'm still going to get a 1 plus 2 plus 6. Sorry, a 1 plus 1 plus 2 plus 6, which is equal to 10. And now I have my numbering scheme set up so that after I go from number 1, I go to the group that is first alphabetized. It's chloro versus ethyl. Chloro wins. So the name of this would be 1 bromo. I'm not going to alphabetize my substituents. 2 chloro. 6 ethyl. 1 methyl. And that is a cyclohexane. So that would be the correct name for that molecule. So again, the first rule is you have to have the lowest sum of substituent numbers. And then if you need to break a tie, you would either, start at the first alphabetized group, or you would then start at your number 1 position and then go to the higher alphabetized group. And if you have 2 groups attached to 1 carbon, numerically that must be number 1. Okay. So that's the basics and the possibilities in terms of naming cycloalkanes. And it would be the same whether it was a 3, 4, 5, 6, 7 membered ring. We would follow the rules like that.